Hello, and thanks for waiting. Welcome to our course titled Networks Illustrated, Principles Without Calculus. My name is Chris Britton. I'm a third-year PhD candidate at Princeton University, and I'll be teaching this course along with my advisor, Professor Meng Chang of Electrical Engineering at Princeton University. In this lecture, I want to give an overview of what we will be learning in this course and how we will go about learning it. So the first thing that probably comes to your mind is, what is a network? Well, if you look that up in the dictionary, you come up with some pretty complicated definition. For instance, an openware fabric or structure in which cords, threads, or wires cross at regular intervals. So we would have some wires maybe that are crossing at some regular intervals. Or another one, a group of interconnected via cable and or wireless computers and peripherals that is capable of sharing software and hardware resources between many users. So there were many complicated terms there. We heard, users like you or me that are connected over maybe wireless or along cables. So those two definitions are pretty complicated, and they probably leave you with a big question mark. So now, let's try something a little simpler. What about a group of people, like you or me, or things like smartphones, laptops, desktops, or tablets that are all connected in some way? Now, these connections might be over wires or cables, or they might be over the air, like over a wireless interface. Or they could be social connections, for instance on Facebook, if you and I are connected and become friends. So hopefully this makes a little more sense. You may have a nice light bulb on your head right now. So these definitions on the left-hand side will become clearer to you as we go throughout this course, but we'll stick to this definition for now. Now, where are these networks? Well, simply put, they're everywhere. We have social networks like Facebook, Twitter, or YouTube. And on Facebook, we have networks of friends, friend relationships. On Twitter, we have networks of following relationships, who you're following and who's following you. And on YouTube, we have networks of people who are talking, or we have networks of movies, videos. We also have technological networks like cellular or 3G, maybe 4G that you might use on your smartphone. We have Wi-Fi, for instance, on your smartphone or on your laptop device. And we also have the internet, which is basically where all of these tasks run on top of. So you see we have a wide variety of technological networks, starting with 3G, Wi-Fi, or the internet as being just three examples. And we also have economic networks, which is basically how we're priced for all of these services that we use. We have to pay for the internet, and that determines how we pay and how much we have to pay. So if you think about it, our lives would be a lot different if we didn't have all of these networks. So what do you need to know for this course? You probably saw a similar course, which was called Networks, Friends, Money, and Bytes, that we have had on Coursera twice already. In that one, we had a prerequisite of calculus and linear algebra, or dealing with logic matrices. So we may have written some complicated equation that looks something like this. Pi of t is equal to gamma I over SIR I of t times Pi of t minus 1. So we have a lot of symbols, for instance this P right here. We have a lot of subscripts, for instance that I, and things like SIR and T for time, which make it mathematically convenient to write down, but it doesn't help the fact that it's pretty confusing. So in this course, we thought a lot about how to present the material, and now we have two different prerequisites. The first one is chalkboard math, if you will, like addition, multiplication, subtraction, and division, and the second one is just a desire to learn. So we realized that we can take this equation right here and write it in its English form, a lot simpler. So we have here the next power, which your cell phone will transmit at, is equal to this thing called the ratio times the current power. So now all we need to do is multiply these two things, and we'll get the next power. That looks a lot simpler than this equation up here. So we'll be using chalkboard math rather than calculus and linear algebra. And hopefully that makes a lot more sense. Now, how are these lectures presented? Well, we thought a lot about what the best teaching style, or pedagogy, if you will, is for this type of material. And we summarize that in 3 A's. The first one is analogies. Networks lend themselves very well to analogies, things like transportation networks or the postal system. For instance, we can relate congestion in the internet to what happens when you sit in a traffic jam. And we can relate how pieces of data get through the internet to what happens when you send a mail to someone, and how it goes to all intermediate post offices along the way. The second A is anecdotes. So a lot of times the best way to explain some of these networking concepts is to tell stories and history about how they came to be in the first place. And the third A is animations. It's probably the most important. So indeed, they say that a picture is worth 1,000 words, and networks are no exception to that. So we'll be using a lot of pictures to explain a lot of these tools. So now, each of these lectures revolves around a few key principles. Namely, we have 8 of them, which we call 8P. And these principles are simple phrases that could probably fit within these 2 quotation marks right here. So they're 3 or 4 words each. And they summarize a vast amount of network ideas. And so we'll go through some of these principles. Specifically, we'll go through 5 out of the 8 of them, and we'll go through some of the topics involved in them. The reason we're only going to do 5 is because we only have 6 weeks together, so we'll just do as much as we can. Now the question is, what are these principles? So let's briefly go through them.